Hey guys, this is a video for your extension today, April 23rd on Friday. We're going to be talking about what compound probability is and some examples of how to do it. So compound probability is what could happen when you have more than one action. So for example, flipping a coin twice, or rolling two dice, or flipping a coin once and rolling the dice once. So there's more than one action that's occurring. So because you want to find out what could happen, we're finding the theoretical probability for each of these actions and then combining it into a compound probability. So there's a couple ways to do it. The first way is to create a tree. So first thing you need to do is determine the number of actions or events that you're going to be doing. This helps determine how many branches your tree is going to have. That's why they call it create a tree. So for the first action, by flipping a coin once, I could get heads or tails. So that's my first action. Now, the second action is when I flip it again. So these are our possibilities when we flip it a second time. Now, because a lot of that depends upon what we got at the first time, it becomes a compound probability. So for example, if I flip it once, I get heads. If I flip it again, I could get heads or I could get tails on that second flip. And then all of a sudden, it starts branching out from there. On the third flip, I could get heads or tails. Or if I flipped heads and then tails the second time, on the third flip, I could get heads or tails. Or if I did a tails on the first, heads on the second, I could do heads or tails on the third. So all of a sudden, this branch, this tree starts really growing. And these can get really big and really tricky to maneuver. So you got to be careful with it. So this is action 1, this is action 2, this is action 3 of what could happen. Now the possible outcomes look like this. If I get a heads, and then a heads, and then a heads, well, there you go. Or I could get a heads, heads, and then a tails, or a heads, tails, and then heads, or a heads, tails, and tails. Or maybe I get a tails the first time. I could get a tails, heads, and then heads, or a tails, heads, and then tails. Or I could get a tails, tails, heads, or tails, tails, tails. So you can see that depending on the number of possibilities for something, these trees can get really, really messy. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 possible combinations of outcomes. So the reason I'm bringing this up is because you might be given a picture that looks like this and then asked a question like this. So what is the probability of the coin landing on tails exactly 2 times? So what I want you to do is I want you to pause the video and I want you to count out the number of outcomes that give you tails exactly twice. So pause it right now. Okay, so welcome back. We're going to count the number of times tails comes up exactly 2 times. Well, in this first one, I don't see tails coming up at all, so that's out. This outcome, I see tails coming up once, but we're looking for exactly 2 times, so that doesn't count. I see tails coming up once on this one, so nope, that's out. Oh, here we go. So here's one where I can get tails exactly twice. This outcome, nope, I can only get it once. Oh, there's another one. Or here's another one. Now this last one, I get tails 3 times, but that does not match what the question's asking. It wants to know exactly 2 times. So that one's out. So I can get tails twice, exactly 2 times, 3 different ways out of 8 possible outcomes. So then my probability of getting point exactly 2 times would be 3 out of 8. So trees are one way to do it. The next way is to create a table. With a table, this might actually look somewhat familiar because you may have done this when you were doing genetics in science this year. We've got a table here and we're going to crossbreed, I guess is what science would call it, playing cards and flipping a coin. So I'm going to list out my possible outcomes when I flip a coin and draw a card from a deck. So I get heads and I get a diamond. I'm just going to do H and D. Well, or I could get heads and clubs. Or I could get heads and then breed it with hearts. Or heads and spades. Or maybe I get tails. So maybe I get a tails and a diamond. Or tails and clubs. Or tails and hearts. Or tails and spades. So these are the possible different combinations when you flip a coin and choose a random card from a deck. So again, we bring this up because you could get a question that looks like this. What is the probability of getting heads and heart? So I want you to go ahead, pause the video, and determine what's the probability based off these outcomes of getting heads and hearts. Go ahead and pause it. Okay, so if I'm looking here, I'm looking for heads and hearts. That's going to automatically disqualify all of this bottom row down here because those are all tails. Heads and heart, well, that's a diamond. That's a club. Oh, there's a heads and hearts. And heads and spades, so that's out. So there's only one way I can get heads and a heart out of 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So then my answer to this question would be, probability of getting heads and heart would be 1 out of 8. So tables are another way you could do it. Tables are really good if you only have 2 actions you have to worry about. So action 1 is heads or tails. Action 2 would be diamonds, clubs, hearts, or spades. If you're trying 3 or 4, this can get kind of messy. So 3 or 4, you probably want to go with a tree or something. So a list, you might see outcomes listed out like this, where they're kind of in parentheses. So we bring this up because you might get asked a question like this. What's the probability of a coin landing on heads at least 3 times? So you have to think back to what at least means. At least means greater than or equal to. So we can be more than 3 or we can be exactly 3. We're looking for heads. So this one has 4 heads and 4 is greater than 3, so that one's okay. This one has 3 heads, so we're still meeting the criteria, so we're good. This one has 3 heads, so we're still meeting criteria. This one has 2 heads, and 2 is not greater than or equal to 3, so that one's out. This one here gives us exactly 3 heads, so we're good. This one gives us 2 heads, so nope, that's out. 2 heads again, you're out. Only 1, yep, you're out. Or, how about this one? Well, I get tails the first time, but I get 3 heads after that, so I'm good. Tail, ooh, I only get 2 heads on that one, so that's out. 2 heads on that one's out. This one has 3 tails, but we're looking for heads, so that's out. This one has 2 heads, you're out, you're out, you're out, and you're out. So it looks like 1, 2, 3, 4, 5 different ways that I could get heads at least 3 times out of how many outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there you go. So if they give you a list and want to know probability, that's how you would do it. If you have to create a list, those can get really tricky really fast. So if it's me, I always refer to a tree if it's 3 actions or more. If it's 2 actions, then I would recommend a table, but that's up to you. So once you've finished with this, we're going to have you work on your own problem. For this problem, you are welcome to use a whiteboard. You're welcome to use just a scratch paper. You're welcome to do it alone. You're welcome to do it with somebody else that has finished the video. You can choose how you want to do it. So we're going to talk about McDonald's Happy Meals. So for this, we're going to create a probability tree to determine all possible outcomes. So you go to McDonald's and you can choose from the 4 following options. For 4 quart. Okay, we're going to start again. Okay, so for McDonald's Happy Meals, we're going to create a probability tree to determine all of the possible outcomes. You go to McDonald's and you can choose from the following options. For a main course, you can choose either a hamburger, cheeseburger, or a 4-piece chicken McNugget. For sides, you can choose fries, yogurt, and apple slices. For a drink, you can choose chocolate milk or soda. And what I want you to do is to create a tree, like we did earlier, to find out how many different combinations of food you can get for McDonald's. So go ahead and pause the video now and see what you can come up with. Okay, welcome back. So hopefully you've gone through and tried to come up with a probability tree to determine how many different combinations of food you could get. So I'm going to go ahead and give you the answer now. In a moment, anyways. I want to show you guys an easier way to find the number of different outcomes. So if you're asked to find out how many combinations can be created from your choices, there's an easier way of doing it. You multiply the theoretical probability of each possible outcome. So what I mean by that is this. So what number of outcomes when rolling 2 dice? Well, the theoretical probability for rolling any number on a 6-sided dice is 1 out of 6. So rolling a 1, you have a 1 out of 6 chance. Rolling a 2, you have a 1 out of 6 chance. So if you do it again for a second dice, the theoretical probability is still 1 out of 6. So what you can do is multiply 1/6 times 1/6, and that will give you 1/36. So that means that there are 36 possible outcomes when you roll 2 dice. And that's something we explored at the beginning of the week with the horse race dice activity. So we're going to apply that now to the McDonald's question. Just have you check your answer. So you were given main course of hamburger, cheeseburger, 4-piece McNugget. So there are 3 possible outcomes you could choose from. So we're going to say it's 1 out of 3. For sides, fries, yogurt, and apple slices, you also have a 1 out of 3 chance of selecting something random. That's kind of an ugly 3. Yeah, it'll work. For drinks, chocolate milk or soda, you have a 1 out of 2 chance of selecting something. So that means you're going to do 1/3 times 1/3 times 1/2, and it equals 1/18. What that means is that there are 18 possible outcomes that could be made from those choices. Once you've gone through and done this activity, whatever time is remaining is yours to work on something quietly. You are welcome to hop into Prodigy or work on something from another class. If you wrote down some stuff that you need to work on from your report cards, this would be a great time to do it. Choice is yours, but please work quietly while others are focused on what they're doing. Have a great day, guys. Have a good weekend.